Hello, let us continue the miscellaneous exercise chapter 2, question number 12. Nine pi by 8 minus 9 pi by 4 sine inverse of 1 by 3 is equal to 9 by 4 sine inverse of 2 root 2 divided by 3. We have to prove this. LHS is equal to, we can take 9 by 4 common. We have pi by 2 minus sine inverse of 1 by 3. Pi by 2 minus sine inverse 1 by 3 can be written as cos inverse of 1 by 3. Using the formula, sine inverse of x plus cos inverse of x is pi by 2. Therefore, pi by 2 minus sine inverse x will be cos inverse of x. But here the answer is given in terms of sine inverse. So let us change cos inverse to sine inverse using triangle method. 1 by 3 is a positive value. So first quadrant angle. Cos is adjacent by hypotenuse. We can find the opposite side. Root of 9 minus 1, which is root 8. Root 8 can be written as 2 root 2. Therefore, it becomes 9 by 4 sine inverse of opposite side by the hypotenuse. And this is the right hand side to be proved. Question 13. Solve 2 tan inverse of cos x is equal to tan inverse of 2 cosecant x. We will use 2 tan inverse of x formula. We have 3 formulae, one in terms of sine inverse, the other one cos inverse, and the third one tan inverse. Since the right hand side has tan inverse, we will use tan inverse formula. Tan inverse of 2x by 1 minus x square, and the condition is absolute value of x should be less than 1. Therefore, the left hand side becomes tan inverse of 2 times cos x divided by 1 minus cos square x equal to tan inverse of 2 cosecant x. Now, taking tan on both sides, this tan inverse function will get cancelled. Taking tan on both sides. So tan and tan inverse will get cancelled. 2 cos x divided by 1 minus cos square x is sin square x equal to, here also tan inverse function will get cancelled. We get 2 cosecant x. Cancel 2. Cos x by sin x is cot x into 1 by sin x is cosecant x is equal to cosecant x. If you cancel a common factor from an equation, don't forget to equate it to 0. But cosecant x never takes the value 0. And the remaining term is cot x, which is 1. Therefore, x is equal to pi by 4. This is the solution. Question 14. Solve tan inverse of 1 minus x by 1 plus x is equal to half tan inverse of x, where x is greater than 0. Tan inverse of 1 minus x by 1 plus 1 into x I can write, which is equal to half tan inverse of x. Now let us use tan inverse of x minus y by 1 plus xy formula, which is tan inverse of x minus tan inverse of y. Therefore, the left hand side becomes x is 1 and y is x here. It becomes tan inverse of 1 minus tan inverse of x by this formula equal to half tan inverse of x. Tan inverse of 1 is, these two are like terms, we can add them, so it becomes 1.5 tan inverse of x, that is 3 by 2 tan inverse of x. Therefore 3 by 2 tan inverse of x is equal to, tan inverse of 1 is pi by 4. Tan inverse of x is pi by 4 times 2 divided by 3, which is pi over 6. X is tan of pi by 6, which is 1 by root 3. So x is equal to 1 by root 3 is the solution. Question 15. Sine of tan inverse of x is equal to, we have to find. Since we have sine outside, we will change this tan inverse to sine inverse using triangle method. Here I can take x as x divided by 1. Tan is opposite side by the adjacent side, so hypotenuse will be 1 plus x square. Therefore, sine of tan inverse of x can be written as sine of sine inverse of opposite side by the hypotenuse. Now sine and sine inverse could be cancelled. Therefore, the answer is x divided by root of 1 plus x square.
The correct option is D.
Question 16. Very important question. Sine inverse of 1 minus x minus 2 sine inverse of x is pi by 2. We have to solve for x. I am taking the second term to the other side. Therefore, it becomes pi by 2 plus 2 sine inverse of x. Now taking sine on both sides, it becomes sine of pi by 2 plus 2 sine inverse of x. Let us use sine pi by 2 plus theta formula. Pi by 2 plus theta is a second quadrant angle. In the second quadrant, sine is positive, but for pi by 2 we change the ratio, so it becomes cos theta. One minus x is equal to cos of 2 sine inverse of x. Then we are going to use cos 2 theta formula, but if it is in this form, we won't think about the formula. So let us substitute sine inverse of x as theta. So x will be sine theta. Now we have cos 2 theta. So cos 2 theta has 4 formulae, but we need to use the formula which involves sine because our substitution is in terms of sine. So cos 2 theta formula is 1 minus 2 sine square theta. You have to be thorough with all the trigonometric formulae, otherwise this chapter will be difficult. Now let us substitute for sine theta. Sine theta is x, so it becomes x squared. 2x squared minus x is 0. Taking x common, we have factorized. Either the first factor must be 0 or the second one must be 0. So from this we get x is equal to half. Now, if you get more than one answer for inverse trigonometric equation, check your answer. We don't have any condition to check in this question. So let us substitute in the given equation and we will do the checking. So first value, x is equal to 0. Let us substitute in the given equation sine inverse of 1 minus x minus 2 sine inverse of x. We should get pi by 2. Sine inverse of 1 minus 0, which is 1, minus 2 sine inverse of 0. Sine inverse of 1 is pi by 2. Sine inverse of 0 is 0. So we get the right hand side. Therefore, x is equal to 0 is a solution. Let us check the second answer. Substitute in the given equation. Sine inverse of 1 minus half is half minus 2 sine inverse of half, which is minus sine inverse of half, which is minus pi by 6, and it is not equal to pi by 2. We are not getting the right hand side, therefore x cannot be half. Therefore the solution for this equation is x is equal to 0.
The correct option is C.
Question 17. Tan inverse of x by y minus tan inverse of x minus y by x plus y. This is tan inverse. We can use tan inverse of x minus tan inverse of y formula, or you may write this in the form x minus y by 1 plus xy and use the formula. I am going to use tan inverse of x minus tan inverse of y formula. It becomes tan inverse of x by y minus x minus y by x plus y divided by 1 plus x divided by y into x minus y divided by x plus y. Take LCM. The LCM in the numerator is y times x plus y. So we get x into x plus y minus y times x minus y. And the LCM in the denominator is also y times x plus y into x plus y plus x into x minus y. Open the brackets. X squared plus xy, don't forget to distribute the negative sign, plus y squared divided by xy plus y squared plus x squared minus xy. This becomes tan inverse of x squared plus y squared divided by x square plus y square, which is 1. Tan inverse of 1 is pi by 4. So the correct option is C. Example 11. It is an important question. Show that sine inverse of 12 by 13 plus cos inverse of 4 by 5 plus tan inverse of 63 by 16 equals pi. Let us take the left hand side. We will change them to tan inverse using triangle method. Sine is opposite by hypotenuse, therefore adjacent side becomes 5. Cos is adjacent by hypotenuse, therefore the opposite side becomes 3. Sine inverse of 12 by 13 becomes tan inverse of 12 by 5. Plus similarly, let us change cos inverse to tan inverse. It becomes 3 by 4. And the third term is already in terms of tan inverse. Now I'm going to use tan inverse of x plus tan inverse of y formula, but x into y is 9 by 5, which is not less than 1. So I cannot use that formula, tan inverse of x plus tan inverse of y. So let us change this tan inverse to cot inverse. Cot inverse of reciprocal 5 by 12. Here we have used the formula tan inverse of 1 by x is equal to cot inverse of x when x is greater than 0. Now I'm going to use pi by 2 minus tan inverse of x formula, which is cot inverse of x. Pi by 2 tan inverse of 3 by 4 minus tan inverse of 5 by 12. In the previous step, we have used tan inverse of x plus tan inverse of y is equal to pi by 2 formula. Now for these two terms, we will use tan inverse of x minus tan inverse of y formula, which is tan inverse of x minus y by 1 plus xy, and the condition for this formula is xy greater than minus 1. And x is 3 divided by 4, y is 5 divided by 12, and of course it is greater than minus 1, so the formula is applicable. We are using formula for this. It becomes tan inverse of 3 by 4 minus 5 by 12 divided by 1 plus 3 divided by 4 into 5 divided by 12. And the last term is tan inverse of 63 by 16. Let us simplify this ratio. Tan inverse of, take LCM, 4 into 12 is the LCM, 36 minus 20 divided by 48 plus 15. Thirty-six minus 20 is 16 and this is 63. Now I can write tan inverse of 1 by x as cot inverse of x when x is positive. This becomes cot inverse of reciprocal formula and plus tan inverse of 63 by 16. And cot inverse of 63 by 16 plus tan inverse of 63 by 16 is pi by 2. By this formula, tan inverse of x plus cot inverse of x is equal to pi by 2. Therefore, the answer is pi. So many methods are there to do this question. You can follow the textbook method also. Example 12. Simplify.
This is the given question.
Now to use the formula of tan inverse of x minus y by 1 plus xy, which is tan inverse of x minus tan inverse of y. Here we need 1. So to get 1 here, let us divide by b cos x. We get tan inverse of, each and every term should be divided by b cos x. A by b minus b gets cancelled. Sine by cos is tan x divided by b cos x by b cos x is 1 plus a by b tan x. Now use the formula. It becomes tan inverse of our x is a by b here and tan inverse of y is tan x, which is equal to tan inverse of a by b. Tan inverse of tan x becomes x. Example 13. Solve. Tan inverse of 2x plus tan inverse of 3x equals pi by 4. We will use tan inverse of x plus tan inverse of y formula, which is tan inverse of x plus y divided by 1 minus xy, and the condition is xy less than 1. Our x is 2x here and y is 3x. So x into y will become 6x square should be less than 1. So we will check this condition after we get x values. Now using this formula, the left hand side becomes tan inverse of 2x plus 3x divided by 1 minus 6x square equal to pi by 4. Let us take tan on both sides. Tan and tan inverse will get cancelled. Here it becomes tan pi by 4, which is 1. Cross multiply and get the quadratic equation. Equal to 0. Now we have to factorize. Product is minus 6. Sum should be 5. So I can split the middle term as plus 6x minus 1x. You have to be careful, don't take 3 and 2. You cannot split the middle term using 3 and 2. So plus 6 and minus 1. 6x is common from the first two terms, and from the last two terms minus 1 is common. X plus 1 into x, 6x minus 1 is equal to 0. So x is equal to minus 1 is one solution. X is equal to 1 by 6 is the other solution. So I have told you, while solving the inverse trigonometric equations, if you get more than one solution, always check your answers. You can check in the given equation, or you may check in this given condition. The condition was 6x square should be less than 1. So let us check. The first solution is x is equal to minus 1. 6 into minus 1 the whole square, which is 6. 6 is not less than 1. Therefore, x is equal to minus 1 is not a solution. Now we will check the second result. X is equal to 1 by 6. 6 times 1 by 6 the whole square, which is 6 by 36. Which is equal to 1 by 6, and it is less than 1. Therefore, the solution is x is equal to 1 by 6.